Hi, my name is Bill Baker. I'm the partner in charge of structural engineering for the Skidmore, Owings & Merrill office here in Chicago. I had the pleasure of leading the team of structural engineers who designed the Burj Dubai. My engineers and I work very closely with the architects, the electrical engineers, mechanical engineers, and plumbing engineers, as well as some very important outside consultants such as the elevator consultants, the wind tunnel consultants, and others to develop this design. Now, this design really is a Swiss watch. We need to work very closely with all these other professionals to come up with this building that's quite integrated. Now, the structure itself is the part of the building that resists the natural forces of nature, such as wind, seismic, and gravity. But by doing this in a smart way that works with all the other systems of the buildings, you get an economical building which you could actually afford to build, which is very important when you're trying to achieve something of this monumental height. Now, one of the other very important things about a tall building is the way it behaves with the wind. Now, if you have any object in the wind, as the wind flows past the object, it'll peel off and create vortices. And each time one of these occur, they put a little pulse perpendicular to the direction of the wind. And if these pulses occur at the natural frequency of the tower, you can get very large forces. This is very much like a child on a swing set. When you have a child on a swing set, the child will sit on the swing, and by kicking their feet at the natural frequency of the swing, they'll get going higher and higher and higher and higher. Now, in a tall building, what we try to do, we try to confuse the wind. Because a building will also be an oscillator, like a swing is an oscillator, it'll have a natural frequency where it tends to want to vibrate. And if the rate at which these vortices occur matches the natural frequency of the building, you can get quite large forces. So the rate at which these occur are related to the width of the object and the shape of the floor plate. And if you vary those two parameters, you can essentially confuse the wind. It's like having a child on a swing where one foot is going up and the other foot's going down. The child wouldn't go very far at all. Every segment of the building behaves differently than the segment above it or below it. Say the wind is coming from this direction. Here you see it's hitting a broad face, and the vortices would peel off. But if the wind was coming at this direction, it hits essentially what we call a cutwater, and it's fairly benign. So what we want to do is we want to control the behavior of the building, or control the forces that are on the building when the wind is hitting the broad face. And we do that by changing the shape of the floor plate. We found that there was one particular direction that was more active than others. So we actually rotated the building 120 degrees to put that more active direction in a direction where the wind is less likely to come from. Initially, the setbacks occurred in a counterclockwise manner, but based on the wind tunnel studies, we concluded it was beneficial to have the steps occur in a clockwise manner. So through this process of changing the shape of the building, we were able to greatly reduce the forces on the building. And without that process, and without working with the wind tunnel consultants, doing many, many tests in the wind tunnel with RWDI, we would not have been able to achieve a building that is as tall as this building.
My name is Lawrence Novak, a structural engineer working on the Burj Dubai Tower. In this student demonstration wind tunnel, you can see that as the wind blows at a rectangular building, the vortices become organized and cause motions perpendicular to the wind direction. A vortex is a swirl of air similar to a mini tornado that rolls past the building. When we replace the rectangular building with a tapered triangular building similar to the Burj Dubai Tower, the vortices cannot become organized, and this greatly reduces the forces and motions. In a commercial wind tunnel used in the design of the Burj Dubai Tower is based on the same principles as this simple demonstration, but with very precise geometry and sophisticated instrumentation.